Welcome to Mastering Solutions. I've gone ahead and drawn a diagram of what's going on so we can do our ray tracing. This is how you represent a diverging lens, this kind of a inverted arrow thing here. We have our two focal points, and they tell us that we have an object 15 centimeters in front of it, and our focal lengths are 10 centimeters. So we have 10 here, 10 here, and then our object is going to be just a little bit more, about a third out. So I'll say about like this. So now remember, we've talked about it on several of the past problems. Anytime you want to do a ray tracing, we could do an infinite amount of different lines here to figure out where the image is going to form. We need a minimum of 3. Those 3 are going to be parallel to the focal point, center of the lens, and then focal point to parallel. If you remember those 3 things, say that over and over on all these problems. So when you get to a test, if you get stuck and you get stressed because you can't figure it out, if you go back to this, you can do any ray tracing question. So for this one, the diverging ones are a little trickier, but they're not too bad. We'll start with a parallel. So anytime you have parallel light rays, by definition, it'll go through the focal point. With this though, it's a diverging lens though, and so how we know how much it's going to go is if we come from this focal point, that'll indicate to us how much it's going to diverge. This will go like that. So then I can go in and erase that there. Okay, so that's how we'll have this one. Now to do the second one, we need to go through the center of the lens. And so we'll have right there through the center. And then the last one, we go from the focal point to the parallel. So with this last one, this one is where students get tripped up. Just draw a line as if you're going to the focal point. And then instead of going to the focal point where it hits the lens, now we're going to have parallel or collimated light. So it'll look like that. These on this side, obviously it's a diverging lens, so they're not going to intersect or cross at all. So we have to extrapolate them back. So this one, we'll start there since it's parallel. This one's going to come back about like that. And then this one through the center of the lens already crosses here. So you can see the focal point of our image where all of the lines intersect is right here. So since it's on the upstream side of the lens, we have a virtual and an upright image. And if we were really accurate and did graph paper and were really precise in all of our measurements, we could figure out and calculate exactly what the image distance from the lens is. We're obviously not doing that, so we can also use the thin lens equation. They might not ask you to do this in your question, but it's good practice. And in case they asked you in your question, I'll cover it. So we have the 1 over the focal point is equal to 1 over the object distance plus 1 over the image distance. We're trying to solve for the image distance. So if we subtract over 1 over s, we have 1 over the image distance is equal to 1 over f minus 1 over s. When we plug our values in, we have 1 over the image distance is equal to 1 over a negative 10, so negative 0.1 meters. These do need to be in meters. If you leave it in centimeters, even though they're all the same units, it won't give you the correct answer. And then we're going to minus 1 over the object distance, which we said was 15 centimeters, so 0.15 meters. We have 1 over negative 0.1 minus 1 divided by 0.15, and that gives us negative 16.67, and the units are diopters for lenses. That's not what we want though. We don't want diopters, we want the image distance. So if we take the inverse of that, we have 1 divided by the answer gives us negative 1.2. So we have negative 6 centimeters for our image distance from the lens. Our focal point was 10, so you can see we actually got pretty close. That's about 6 centimeters right there. The negative indicates that it's on the upstream side of the lens and it's virtual and upright. So here are your answers for this question.